Hi, welcome to this Programming for Cultural Heritage demo video. Today we're going to look at working with simple functions and how you can use them. So in most of our kind of programming so far in the course, we've been doing, basically we just write Python into a Python file and the interpreter runs it for us, and we don't really kind of think about functions so much or thinking about the structure of the code. We do use functions constantly when we're working with Python because there's a lot of functions built in. So for example, the print statement, that's a function that's built into Python, and there's many other kind of default functions that are built in, like len. There's also these methods built into libraries like loads for the JSON library that, or the get from the request library. These are kind of functions built into those libraries, and we've been using these all the time. But we haven't really been defining our own functions usually. Mostly we just kind of let Python run through the script, and we don't really kind of define our own kind of functions for it to do specific things. So normally when we run a script, the order, it just kind of starts at the top of the script and just runs through it, right? It starts at line one and just goes through it to the very end. And then once it hits the end, the script's over. What you can do with functions is kind of create your own little modules of code that does some specific task. And functions are built around the idea of passing it data. It does something with that data and then returns it back to whatever called it. So we could kind of do like a really simple kind of example with this. So I'm going to go to my downloads and make a directory called functions. Um, And so, we could have you'd want to use a function for a specific task, right? And the idea behind functions is that you'd want to reuse the code. It's something you'd want to do over and over again. So if you're only going to be doing something once in a script, then you wouldn't want to do a function because it would be more work to write a function for it than just to write the one kind of line of code or the couple lines of code that does it just once. So you really want to think about functions as a way of repeating code over and over again on demand to do a certain task. And so it really depends on what task you want to be doing. But so say, for example, we had a list of strings. So we say string list. And these had various strings in it. And so here I'm like hard coding it, but these could be strings coming from an API, coming from a web scraping thing, coming from a CSV file, anything, right? So it could be all sorts of kind of data in here. There could be data just as plain. There could be data that's maybe has like trailing spaces in it. There could be data that has, it's just a number. It could be as a string. It could be, has leading spaces. It could be all sorts of stuff. And so what you can do, say you wanted to write a function that kind of normalizes these strings and maybe gets rid of anything that's like a number or something like that. Um, you could write that code, here, and you say for s in string list, and then do your kind of operations here. So you might say like, okay, first thing I want to do is make sure that has no leading spaces or trailing spaces behind it. So you could say s, the string is going to equal itself, and we're going to strip out any of these leading or trailing spaces. And you could say, like I always want it to be lowercase, so we could say, okay, s equals itself, but make it lowercase. And so if you're only going to do this once, it makes sense just to write it like this, right? Like you just do it in line with the code and you go on to your next step or whatever, right? But say, for example, you're going to be doing this operation over and over again in various parts of your program, right? Like you might be opening up multiple APIs, you might be also opening up different files at different times, and you always wanted to kind of normalize these strings or something like that. So in that case, you probably wouldn't want to have to keep repeating this code over and over again everywhere you go, right? Because you would find yourself, you'd write some more code here, and then, you'd do the same thing over and over again, but with just different sources, right? It might be a different variable name at that point and different kind of data coming in. But the idea with functions is that you can write the code once and then invoke it wherever you need it, and it will just do the operations that you want it to do. So in Python, to define a function, you start with def, and then you give it a name. So this is like a variable name. So we could say something like str normalize or something like that. And then you do parentheses, and then you do a colon, and anything indented underneath of it is then the function. And so a function can't really work unless you give it something to do, or really, mostly you need to give it something to do. And so to give it something to do, you have to pass parameters to it. And so, for example, in our function that we're writing here, we would expect that the string normalizer, you would need to pass it something to work on. You need to pass it the string. So we could say something like string to do or something like that, right? And then this variable would be available inside of our function, and you can do whatever you want with it. And then the last thing you want to do with a function is you always probably want to return something back to where it came from. So in this case, we'd say return, and then we'd say new string or something like that. So we haven't defined this yet, but we're assuming that string to do is going to turn into a new string at some point, and then we're going to return new string. So we kind of have the structure of the function laid out here, right? We have the kind of the skeleton of it. The thing that we'd want to do now is actually what are we going to do to the piece of data being passed to it? And so in here we could do all of the normalization steps that we were going to do before. So we could say, okay, we're going to make the new string is going to be equal to string to do, but then we're going to say, okay, take the new string and strip out any sort of leading or trailing spaces, and then we're going to take the new string and make it lower case, and then we're going to return the new string, right? This is it's a hypothetical kind of situation. It's a very simple function, but it's the same idea. You basically have this little module or this little kind of unit of work that you're going to be sending it something to work on, and it's going to return the results of its process. So in this case, if we wanted to invoke this function, we would just basically say its name and then pass it something to work on. So in this case, we could say, just some string like this. And we can just say test equals this. And then let's just print out test. So what we would expect to see is that, these leading spaces are removed, or the trailing and leading spaces are removed, and it's, it looks a lot, it fits into our whatever we're trying to do here. So let's run this, Python 3 test. Right, and so you can see that there's no leading or trailing spaces with this result. And so you can, do this over and over again. You can send it all, work to do wherever you want to send and invoke the function. It can be, reused over and over again wherever you want it to be reused. So, and if we ran this, it would run each one of those, and it would work. So, if we wanted to normalize all the characters in the string list that we did before here, we'd say like we still have to say for s in string list, and then we'd say, s equals string normalize, and then pass it to it. And then we would do something with string probably, with the s, but let's just print it here. So it's going to be normalizing everything in that list. So, you can use this string function this normalized string function wherever you wanted, and you wouldn't have to kind of type this process over and over again. So when you're writing a function, it really kind of pays to be thinking about like grouping things into units of work. And wherever you find yourself repeating code a lot, that's probably where you'd want to take that code and turn it into a function, so you don't have to keep repeating it every place over and over again. Because you can imagine, like, say in a couple of weeks, I want to say, oh, you know what, I found a new use case or test case where I need to actually normalize a string more and change something about it. Like, so now I'm also going to add this new thing where it takes a string and it splits it on say splits it on the hyphen and returns the first match, right? So say, for example, there's a string now that had like this, and we don't want this part, right? So this function, this method here, split, would split this piece off, and it would just return the first half. So, we just added a new use case to our function. And so if we had this same 4 steps everywhere in our code that does this over and over again, we would have to go find it in each piece of the code and change it so that it now has our new test case, takes care of it. But if we just had one function, we just need to change it in one place, and things are much easier to maintain, and it makes a little bit more sense, right? You don't have all this kind of spaghetti code all over the place doing the same thing over and over again. You don't really need it to. You just have it one place and it does it. So of course, you can pass multiple parameters to a function. You can pass as many things as you want, and there's other ways to kind of have a dynamic parameter names, but just to keep it simple, you can kind of separate them with these commas and pass whatever you want into the function to work on. So functions are super useful. It's a fundamental piece of programming in Python, of course, um, and they're super useful. All right, so let's do kind of a more practical example or real life example, because it might kind of convey the point of functions, or might kind of make it sense to how you'd use them. But until you kind of see how you'd actually use it in something real, it might still be a little bit fuzzy. So let's try using functions with an API. So for example, we can use the Brooklyn Museum API, and let's kind of write a function that pulls back images from their API based on a certain search string, right? So what we can do is, we have to, learn how to use their API to get started with, and learn how to use APIs in Python. So there's a whole video on that. So you should watch that if you're not sure how to use requests and other stuff like that to work with APIs. But we can get started with working on this one by let's make a new file. And so traditionally, we're going to have to work with an API. So we're going to use a couple modules. So we're going to import requests, and we're going to import JSON, right? Because this is a JSON API. And we want to use the JSON module, and we want to be able to talk to the internet APIs by using the request module. So the API URL is for images. So let's work with images. Is /archives/image, archive/image. And the full URL to the API is brooklynmuseum.org/API/v2, and then the endpoint. So the URL for our endpoint is going to look like this: brooklynmuseum.org/API/v2 archive image. And that is this one. And so like most APIs, like we have to pass it some parameters, some arguments here. So you have to pass it, what you're looking for, keywords, all those sorts of stuff. But of course, we also need to pass probably our API key and kind of authenticate ourselves with the API. So if we go to this overview of getting started, or let's see, requests. So they talk about how you can authenticate yourself. And in this specific case for the API, you actually have to pass your API key as a header. So sometimes you pass it as like a parameter in the URL like this, like how they're passing decade here. But other times you need to pass it as a header value. So headers are just kind of metadata built into every internet request, every web request. There's a header built into it. And so they're basically saying set the header API key to your API key, and then you can use use it in a header and use your requests. So it's pretty easy to do with requests. It's not a big deal, but we do need to get our API key in here. And so just kind of for this video, in order not to record my API key because then other people could use it, I'm going to store my API key in a JSON file. So I'm going to make a file called JSON, key.json. I'm going to call inside of there, I'm going to say key, and then my key here. Right, so I'm going to save that and save this. And so I'm going to say with open, and we're going to open a file called key.json as key.json. And then we're going to parse this JSON. So we're going to say key equals JSON.load, and the open file pointer is key.json, and then let's just print it here. So if you run this, it's printing out the entire JSON. So my key is going to be stored in the key. I'm calling it key, so I could print it like this. If I ran it again, it would just print my key, right? All right, so instead of printing it, we could then use it in our API key, somewhere else down the line, using it down here. We just have access to that key, and we can use it whenever we want. So I'm going to go not print it out, but I'm going to go take this file. I'm actually going to go put my real key in there so that we're ready to go. And so now when this loads, key will be my API key. So I'm kind of like hiding it from being displayed here, but it's still, it's a reference as a variable in the code. So I still have it available to access. All right, so that's a little bit of a workaround. If you were if you weren't recording this right for the entire internet to see, you could say key equals my thing right here, right? My key. And that would be fine. You don't have to go through this whole rigmarole to kind of load it in from a JSON file just so it's not visible on screen. Another way of doing this is environmental variables, but we haven't really talked a lot about that before, so I thought this would kind of make more sense just having it in a JSON file because we're familiar with JSON files. Okay, so now that we have the key, we need to basically construct our header to pass to the Brooklyn API. So we're going to make a variable called header, and it's going to be the headers. And for the request library to pass headers, it's a dictionary with key value pairs, and the key is going to be the header you want to set. So in this case, our header is API key. And I know that just from looking at the documentation, it said it should be API key. And then the value of the header is going to be that key because it's the key. If it was really just your key here, you just put your key here. But for me, it's my key stored in the JSON file. All right, so now we built the header, and then we can make the parameters that we want to pass to it. And so the parameters are based on the endpoint you want to use. So we're using the image endpoint. And there's a bunch of parameters here. And then one of them is a keyword. And it says keyword filtered by keyword, the search full text for this key and the images. So the key is the keyword is the key, and we can make up some search term like cats or something like that, or cat, whatever. All right. So we're going to do our request. So we're going to say results equals requests dot gets, right? And then the URL we're going to use is stored in the variable URL. And the headers, we have to pass the headers, and we have to pass the parameters into the request method here. So then this is going to do the requests, and then we're going to store the data in whatever comes back as JSON. So we're going to parse the JSON, loads with the S because it's a string, and we're just going to pull the text out of the results. And then we should hopefully have data stored. Data is going to be some sort of response from the API. It's probably going to be a dictionary or something like that. So let's look at it. And you can see here if this worked by going up and seeing, okay, so this looks like JSON, it came back and turned into a Python dictionary. And so we can see that there's like a message key, an error code key, and then a data key. And it looks like there's stuff in the data key, right? And so one thing we could do is we could loop through the data just to show that it works. So we could say for item in data, and it's actually stored in a key called data, so it's data data. And then each one of these items is going to be one of these things. So we could say something like, we could print out the largest derivative URL, and also maybe the title, right? So let's print out the item title, and let's print out the item's largest derivative URL. And let's like print a little line here just to break it up. All right, so if we run it again, we're looping through the items here. So here's the 1903 survey expedition photograph, one of them. So if we open this in the web browser, we would expect to see an image. Yep. Not sure what that has to do with cats, but maybe cat is in there somewhere in the description. Could be. Let's add S to see if that helps reduce it to the number of things. Advertising card here. Let's take a look at this advertising card. Yep, there's a cat. All right. So that's great. We could do that. But how many of these things are there total? Like how many hits of images are there total? And so what we run into quickly with this API is that you can't actually get a total list of total number of hits from the API. So let's kind of explore the API a little bit more, the results a little bit more in depth here. So let's print this. Let's print out the API results totally, just the full thing, by using JSON to dump the data that we just converted from JSON back into JSON. But this time we're going to indent it by 2, and so we can see a little bit more structured, a little bit more clearly for us. All right, so this is the result. So I'm just going to copy this into our editor so we can kind of take a look at it. And so we can see here, there's only kind of 3 levels here: the message, the error code, and the data, right? And so the data is a list of dictionaries, and it has information about each item. But I would imagine this isn't the entire every item that the Brooklyn Museum has with the keyword cats in it, right? So how many things are in here, right? There's no kind of summary saying, okay, here's the first X number of things out of 100, out of 200, out of 300, right? So in this case, let's actually see how many things total there are. So we could print the data, and remember the items are still stored in a key called data, and we can actually print the length of it. So if you run that, we can see that there's 8 items that came back from there. So let's look at this arguments we can pass to it. So we passed it the keyword already, and let's pass it the limit, an integer indicating how many results to return. So if we change this to limit, and we say, I want to see 100 things. Let's see if that increases the number of items. All right, so 95 things. Let's see if we change this to animal, if we get more than 95. No. If we change this to Brooklyn, do we get more than 95? No. So we can kind of see here that whatever kind of we're setting it to, if we change this number, if we change this to 50, do we just get 50 things? No, we get 95. So it looks like, I'm not sure what's going on with this API, but after a certain limit, let's say if we say 5 things, do we get 5 things? Yes. If we say 20 things, do we get 20 things? Yes. 30 things? Yes. 40 things? No. All right, so I think somewhere between 30 and 40, maybe 35. there's something happens with this API and it just kind of, the maximum amount it's going to give back to you is 95, which is, a little strange, but it's fine because, maybe we do want 95 things. But, there's probably more than 95 images in the Brooklyn Museum with the word Brooklyn associated with it. So we know that there's more than that. So the question is like, how many more are there? And so if we come back here and we look at the documentation some more, it says there's a parameter called total count only. And it says accepts values are 0 for false or 1 for true. If true, the total row count for the query will be returned instead of the normal results. So basically it's saying like, if you pass this parameter, we're not going to send you the results. We're going to send you the total number of results there are for your query. So if for example, we took out the limit and we put in this and we say 1, let's just print data totally out again and see what it says. Right, so now there's no data key. Well, there's a data key, but it's not a list of dictionaries. It's just a number. So it looks like there's 17,000 things with the word Brooklyn in it. Let's look for cats. There's 8 things with the word cats in it. Well, a cat. There's 32. Animals. 16. So, depends, let's go back to cats. How about dogs? 16. So you can see that this is kind of like a two-step process, right? If you wanted to know how many things there are in the API, you have to make one request. And if you wanted to actually search for those things, you have to make and get the results back, you have to make a different request. So what we can do is, this is kind of like a good opportunity to use a function, because the function allows us to do this kind of same code over and over again, but with different parameters. So for example, we could write a function that just talks to the API, and based on something we pass to it, it could either return the total count or it could return the actual data itself. So, because if you imagine how we would use this if we wanted to, we'd have to kind of do this code over and over again, right? So say we needed to find out that there is 17,000 items for the search Brooklyn. If we do that, then we need to do another search saying, okay, now start searching for Brooklyn for real this time. Don't return the number of things, and now start paginating through it, right? So if we wrote a function, we could kind of like collapse all of these kind of use cases into one function that just does everything we need to do based on what we pass it, instead of having to write these requests over and over and over again, and setting up different parameters and different headers each time. We can just have that in its own little function and do it, and it just does it, how we kind of control how it works. So for example, let's do this how we would have to do that if we did not set up a function, and just kind of demonstrate why it would be kind of a bit of a replication of work here. So let's set the limit to 20 things. I'll change the keyword let's change it to bridge and see what it says. All right, so so if we wanted to do this, we first need to know how many things have the word bridge in it, and then we would know how we can paginate through them, right? So for example, let's first set off the count only. So we're going to get the count back, and we will say, let's print this and say there are, and we'll say data results. Let's see if that works. Yeah, so there's 145 results. And so now knowing that, I could know that if I do in groups of 20, I need to do 6 pages, 7 pages um, of requests to get all 140 items back, right? So then I would have to do something like this and like save like the total number of things in a variable. We could say like total equals this, and now I could actually do my real kind of looping, right? So if we look at the documentation, it has a limit that we know about, and then an offset. It says integer indicating which index of the full results to start off. So by default, we start off at 0, and then if we do 20 per page, then that's 20. The next page would be 40. The next page would be 60. You go up by 20 each page, each request you make, because they're not going to send you all 145 or whatever in one go. So if that's the case, we kind of need to keep track of our offset, which starts at 0. And then we could say something like, while the offset is less than or equal to total, make a request. And so now we could do the real piece here where we're actually sending the request. But we kind of have to like repeat this stuff again. The headers can stay the same, but we'd have to repeat the parameters. Because this time we're not doing total count only. We're actually doing the request itself. So we're saying limit, let's do 20 per page, and we'll say offset is whatever our offset is. And the last thing we want to do is increase our offset by our limit size, which is 20. So then inside here, we'd also need to do the request again, right? And let's just print out the length of the data. All right, so if this works, it's going to get the total count first. Then it's going to kind of say, okay, now I know I need to go until it's 145, and then we're going to keep track of what number we're currently at in this offset. It's going to talk to the API to make sure it tells it what page we're on or what offset we're on, and then we're just going to increase the offset by 20 by each loop. So eventually this will get bigger or equal to the total, and it will stop looping. And make sure you have commas where you're supposed to put commas. All right. So that's, if you add these up, this would be 145, right? So it looks like it's working, right? It went through all the pages and it did it itself, did the correct number of loops. So this is fine, but you can start to see that it's kind of messy, right? Like it's starting to have like we're repeating kind of code here over and over again. And so honestly, this is not that bad. This is totally fine. But you can imagine like if you really wanted to kind of package this up and you could be a situation where you're going to be doing this a lot and you're going to be having different kind of requests. You kind of want to normalize this process. This could be a good case for like a function. So for example, let's write a function here. And we're going to say, we'll say a function, we have to come up with a variable name. So something like, we'll do archive search. And so in the archive search, you can think about like what we're going to need to pass to it. So we're going to need to pass like a keyword probably always. And we're going to have to pass like eventually like the limit and the offset. All right, so we have kind of our basic skeleton of the function definition here. We have 3 parameters, keyword, limit, and offset. But if we think about like what do we want this function to actually do, we probably want it to do not just do this basic search where it returns the results, but we also want it to be able to return the count of the results too. So for example, we might want to use this function to say like, hey, give me how many things are actually in the, when you search for cats or dogs or animal or bridge, and then actually then start giving me the results for them too. So we want to kind of collapse both of our pieces of code here that we're doing in both these places into one function so it does them both. So in that case, we might need to be able to pass it some sort of flag to say like, hey, don't do look for the results, just look for the totals. So we probably need another variable here called we could call it like totals um, total only, right? And so when you define a function like this and we don't have optional parameters, all of these parameters are required. But what you can do is kind of set some defaults by saying equal signs and then the value you want it to default to. So for example, we'll have a limit if it's not provided default to 20, or you can have the offset default to a certain number 0, and totals only can be defaulted to, um, you know, 0 is totals only returns, if it's 0, then it returns the result. If it is 1, then it returns the count. Um, so then we kind of made these last three parameters kind of a little bit more optional, that the function will work without them if they're not provided, because they'll have default values already provided for them. All right, so now that we have the skeleton defined, we can move our code into here. So let's move our URL up into here. And then we can move our, let's move the part where we open up the key. We'll just do that up here so it's available throughout the whole program. So key will be available throughout the entire program. And then we're going to move our parameters and our API key header up here. And then we're going to move our requests up here too. And then we can remove our data processing JSON load stuff here. So here's where we need to kind of map our function parameters to the parameters we're going to be sending to the API. So here we can say like, okay, keyword is coming from there. Limit is coming from here. Limit. Offset is coming from offset. And then total count only is coming from total count only. So if we didn't pass it, the last three things, the defaults would be 20, 0, and 0, right? And then like all functions, like we saw in the basic function we did, you need to return something back to where it came from. So then we'll just return the data that it parsed. So let's comment this stuff out. And let's just give our function kind of a test drive here. So let's print out, we'll just keep this separate to make it sense. We'll say R equals archive search. And I want you to look for bridge. So if we don't pass these other three, then it should just look for bridge with the limit set to 20, offset to 0, and total only set to 0. So we should actually expect to see some data come back from there. So let's see what it says. Also, then you gotta put your commas in the right place, right? So try it again. All right, so we can see that worked, right? It passed data to us. Let's try just getting the totals only. So we'll pass a default limit of 20 and an offset of 0. But this time we're going to pass the totals only to set to 1 instead of 0. And let's see what it does this time. Right? So it returned just the data with the totals in it instead of the data with the results in it. But we do notice we still have to pass these two variables parameters in between these two. Because if we didn't pass this one, it would think 0 belonged to the limit and offset belonged to the 1. So the order does matter between, the number of parameters you pass to it. There's a way of doing optional parameters in Python, but we're going to kind of not get into that for this look at functions. So in our case, we just have to make sure that we're passing the total number of parameters it expects for there to be so that it can kind of filter in the values to these different pieces of data. All right, So since we kind of simplified this process, we can kind of simplify the rest of our script by just being able to reuse this function over and over again in different places. So let's say we have our keyword is going to be um, bridge. And then first we want to get like the total count. I'm going to say archive search for this keyword. And this is, offset doesn't matter what we put in here because they don't use for the total counts. So we'll see the total count should be the total data. And so what we can do is actually change the code so that if it is a total count only request, then we could return just the just the sorry, JavaScript notation there. So if it is only the total only count being requested, then we can just return a piece of the data, not the total results, because you could potentially want to see any error message or something like that. But if it's the total only, then it will just return the total only. Let's take a look at that. So now it just returns the number if it's a total only search. Test that. All right, so now what we can do is we have this ability to store the total search. So now the total count's in there. So we can do the same thing we were doing before, define our offset, and the same while loop. Inside of here, we don't need to repeat all this stuff. We just need to make the request again. Keyword. So we'll set the limit to 20. The offset will be whatever offset we have. I'm going to set this to 0. Or we don't even need to include it because it's the last parameter and it will just be set to 0 if there's nothing provided there. So let's see if this works. Print line, data, data. All right, so we weren't increasing the offset there, so we need to make sure to increase the offset by 20 each time. All right, so let's see if that works. All right, so now what we can do is do something with the data, right? If we could save this into one big JSON file, so we can make this like, all results. And we could say, all results equals all results plus the data. And the last thing we do is we could write this out. So if we looked in the directory, we'd see there's the bridge data. You can see that there is 145 of these results. So the point here is that we reduce, a lot of repeating code down into this one function, and it kind of does multiple things for us, really kind of a little bit more elegantly than we would have if we were trying to kind of recreate the thing over and over again, just doing different searches. So now you could reuse this archival search in different pieces of your code, to do different things, or you could even write your own library to kind of interface with the API yourself and kind of write a wrapper around it. So as you can see, you write functions for various things, and you use it to kind of reorganize your code into kind of smaller chunks that can be repeated over and over again wherever you need them. And so you could even write, a wrapper around this API, or you could do whatever you want with this API based on writing a functions to deal with different pieces of it. So functions are super useful. They allow you to kind of organize your code much better into kind of more specific units than you would if you had to kind of like just copy and paste things over and over again, repeating your code over and over again. So if you get to the point where you're kind of seeing that you're writing the same piece of code or the same work over and over again, you definitely kind of think about that being a more of a good use case for a function and applying a function in there instead of kind of just repeating the same thing over and over again. So I think that's it. Thanks for watching, and I will talk to you again